All right, it is 2 hours UTC, and it's time once again for Astronomy Daily Live. This is the Obs-Session. Yes. And so welcome everybody. Welcome. Nice to have everybody here. Come on in. And I'm going to make sure that I assume that my chat is working correctly. Um, So yeah, well, welcome everybody. Gonna sort of hang out here for a little while, make sure everybody's coming in that needs to come in. That anybody who wants to come in, I should say. So yeah, everything's good here. I'm already on target. I've already well, I took my calibration data about an hour ago, right after sunset, and that, of course, went really well. So now I did my star alignment, and that, of course, went really well. Hey there, Tom. Nice to see you. Um, so yeah, did the star alignment. That went really well. My target tonight. Hey there, Bobby. Hey. Um, so my target tonight is XZ Canis Minoris. It's an eclipsing binary star. It's an Algol type of star, and it actually did start its eclipse at around 126 or so. Hey there, Ingrid. Nice to see you in the chat. So I'm out here under the nice, dark, clear Arizona sky. Hey there, Ata. Nice to see you too. Excellent. I'm always glad to see everybody here. So yeah, my target is in Canis Minor, which is right next to Procyon. So I actually used Procyon as one of my um, stars to do the alignment on. So I just needed to nudge it over. I slewed over. I have my chart. I found uh, uh, where I was. I had to move, the telescope over a little bit, and all of that. Well, Ingrid, this is what's called an obsession, an obs-session, and that's sort of a play on words. Um, so I'm out here actually collecting science data. And yeah, I've got the red light, of course, because our eyes aren't as sensitive to red light. So so using red light um, uh, doesn't change my night vision. Now, I'm not doing any visual observing, right? I'm not actually using my eyes. So it doesn't really matter if I've got night vision or not. I mean, I'm staring at a computer screen here, which I've got turned down dark, but I mean, it's really bright. But it, I don't care, right? I'm not using my eyes to do these observations. I've actually got the CCD camera on the telescope, and well, this thing just went south on me here a little bit. Let me so so yeah, I'm actually on target right now, just sort of waiting for it to get a little bit darker. I'm still in astronomical twilight, so I want to give the sky a little bit of a chance to darken up a little bit. Um, so and why is Bobby being ignored? Oh, I don't know. Bobby, you're not being ignored. I said hi to you earlier. Yeah. All right. Well, cool. Hope everybody's doing well out there. I'm just I guess what I'm going to do is I'm going to now sort of switch. you over. I'm just going to change views on camera so it's looking forward instead of um, back at me, and you can see what's on my screen here. So let me go ahead and do that. I'm going to let's see. I'm going to put the flashlight down. I'm going to turn it off. Got a little bit of moonlight out here, so it's not going to be as dark as it can be. But I don't care about that either, right? I don't care about that. Um, Now, Bobby, I said hi as soon as you came in, so you cannot make those kinds of accusations. Those accusations will not stand. All right, so I'm going to switch you guys around here, put you pointing forward. I'm going to get out of the way a little bit, get you situated in here. Don't want to mess with any or cords or anything. And let me get you all squared up here, relatively squared up. That's about as good as we're going to get. So I'll zoom in a little tiny bit here, just to sort of fill the entire screen with what we're seeing now. So here we go. This right here, this little dude right there, is XZ Canis Minoris, and that is my target star. Now I've got this really nice bright star down here too. Um, it's that that star is actually also a variable star, but I'm allergic to moonlight. Um, but it I think is relatively steady. I'm gonna have to check that out a little bit more. But as as you can see, I've got a few other stars here too, right? And so what I can do, and what I'm going to do, right, is I'm going to use this guy, which is just going off the edge here. There he goes. I slewed him back in. So I'm going to use this bright star as a reference, right, against this one. Now, tonight I'm just collecting data, right? I'm not doing any kind of analysis or anything else. My job, right, for the next three or 4 hours, right, is to keep these two stars, and this one, which is my target star, and this one in the same field of view. Do you see how it's slewing down? So I'm going to give it a little bit of a shot. That'll probably track out a little bit, but that's okay. I'm going to lose one image. Let me see if I can square you guys up a little bit here. This is not very pretty. I want to be able to give you the best view that I can. I mean, you guys are paying top dollar for this, so there's a little cosmic ray there. Those come in from time to time. You can see relatively well that the star images are nice and round. So yeah, I'm going to be on this star right here, this guy, for the next 3 hours. Now, I'm actually not collecting this data yet. I'm going to wait. Let's see, it's 2:09 UTC now. I think what I'm going to do, astronomical twilight officially ends at around 2:29 my local time. Um, uh, uh, but I'm gonna cheat that a little bit, and I'm probably gonna actually start collecting data in the next 5 minutes. So I'm gonna let this go another 5 minutes, and I will start actually collecting data at 2:15 UTC. Now, I did actually check the eclipse, at least according to the AAVSO, which is the American Astronomical Variable Star Observers. Um, at least according to their site, the uh, my my little target star here started started its eclipse at 1:26 UTC, so about 50 minutes ago or so, 45 minutes ago or so. So I'm not going to catch the entire event, but mid eclipse is supposed to happen at, I think it said 2:58 UTC, right? So I'm going to catch this thing on the way down, and I'm going to catch it at its minimum, and then I'm going to catch it all the way um, back up. So right now, as we're watching this, it is slowly dimming. Now, it's not dimming by um, very much. This star has actually been looked at a substantial amount. A substantial amount. Um, there's actually a paper that was published back in 1966 that talked about some observation, lots of observations um, of this guy. And there's a little bit of a controversy. Well, not really a controversy, but they're not exactly sure what's going on with this system. There might be a third object involved, right? It's at least a binary system, and in fact, I can talk about that a little bit too. Now, I did make sure to focus as well, so the focus is about as good as it's gonna get, and I'm looking at the star images, and they're a little funky looking. Yeah, they are a little funky looking, but it's probably. I mean, let me look at the seeing here. The seeing isn't too bad, so yeah, I think we're good though. I think we're all right here. So I'm gonna have to um, mess around with the camera alignment a little bit too. I actually bumped the camera when I was moving it out here, and I had to reposition it and stuff. Uh, uh, so anyway, yeah. So this guy up here is my target, XZ Canis Minoris, and it's an eclipsing binary star at least, right? So there are two components to this system. There's um, uh, uh, an A component and a B component, and the B component um, you can sort of visualize is orbiting the A component. Um, and it just so happens that um, uh, um, uh, because of our line of sight, the B component actually passes in front of the A component, and that's what makes the whole thing seem to dim, right? Because the B component is a different spectral type than the um, than the A component, and so it's fainter, and so um, what we're actually observing here is a transit. Um, oh, just lost my reference star there, but I moved the whole thing up, so we should get that back in the next image here. There we go. Yeah. As long as this guy and this guy are in the same frame, I think we are good. So yeah, I am seeing some image distortion. Um, so man, I don't know if I should mess with that. I took my calibrations and stuff. I think I'm going to go with this because it doesn't particularly matter what the shapes of these things are. Um, and you know, they are jiggling around a little bit, so I think I'm all right. I think I'm all right. Okay, well, it is officially 2:15 UTC, so I think that I'm going to actually start on this next image. I'm going to start collecting data. So I'm going to punch that up one and go over here. That's probably going to fall out of the field of view, but the next one, we will see that it actually comes back up. And when it does, I'm going to stop this series. Make sure that it's in there. Yep, we're good. Okay, so now I'm all set to go here. So I just have to set autosave to on. And these are going to be 1-second exposures. And I'm ready to fly. I'm just gonna, so here we go. So for probably the next 3 hours, 3.5 hours or so, this is it. So, yay. Hey there, Andy. Nice to see you in the chat as well. I noticed that you popped in a little bit earlier. So yeah, they've been observing this variable star, this so-called variable star, for quite a while, and you know, studying it closely. Some people have taken data that that's already existed and you know, done their own analysis on it, and it 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 looks like it's probably some kind of a contact binary system, which means that the A and B components are actually touching, right? They're they're sharing, you know, the same atmosphere, right? But there's some indication that there might be a third star involved too. Um, and Andy, as far as planets go, I didn't get any information on that. So I'm I'm thinking at this point um, that that none have been observed, right? But that is sort of a tricky game. Now that's starting to track a little bit high there, so I'm gonna poke this down a little bit. So yeah, this is the only target that I'm gonna be doing all night long here. This is, you know, this is how collecting astronomical data goes. Um, you sit on a target uh, all night, sometimes multiple nights. Um, but yeah, you know, oh, you know, I think the one thing that I haven't mentioned is how much does this star actually dim? Well, according to the literature, well, okay, so according to AAVSO, right, the Variable Star Observer Group, um, this star dims. Let's see which way this is gonna go. Oh, I'm gonna I'm gonna move him back down because he's gonna move out of the field. Definitely, definitely don't want to lose our target star, and we're definitely gonna lose it on this next one. Um, but I just moved the telescope, so it should come back in this next image. You can see some cosmic rays here. I'll see lots of cosmic rays all the time. So that's very typical. There he is. He's back now. Um, so according to the AAVSO, this star varies between magnitude 9.7 and 10.4. So right now it supposedly is dimming, Um, the data that I've seen though has it actually varying a little bit more, maybe almost a magnitude, right? At least according to AAVSO, it should vary by about 7/10 of a magnitude. Um, but some of the data I've seen says that it varies actually a little bit more, maybe uh, one magnitude. But even so, you know, um, uh, um, you know, even a factor of zero point 0.7 magnitudes is really really close to a factor of 2, right? So I mean, um, it's going to be dimming by half its amount. Um, so are we going to notice that? Yeah, I don't know. Okay, that thing is, as you can see, the tracking isn't really all that great. These are 1 second exposures, so even if the tracking isn't great, um, the exposure time is short enough that I don't get a lot of streaking, right? So they're 1 second exposures, and then it takes about 14.2 seconds to actually download the image from the camera to the computer. So yes, Ata, I do consider myself extremely lucky and extremely blessed to be able to be out here in this incredible dark. I mean, it was completely planned, but plans don't always have to go right. But this plan has. So, and that's why I was just so incredibly bummed out when I was noticing that there was some kind of problem, but that problem seems to be partially solved. The I'm looking at the images that I have here now, and they're still not quite right. That little bright star is going off the edge there again, so I'm just move the telescope. I can move the telescope while the image is downloading. Um, and so you'll notice on this next image that um, that everything will have moved up, and that bright guy will be back in the field of view. There he is. Okay, very cool. So that's how I want to keep it. And yeah, I'm just going to sit here and um, um, Andy, I cannot. This is as much of the sky as I can see, and I'll tell you how large this is, right? From this edge over here to this edge over here is about 12 arc minutes, and from the top to the bottom is about 9. So this field of view that you're seeing here is about uh, one fifth of the area of the full moon. It's a very 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 small piece of the sky, very very small. Um, in fact, what I can do, I'll pull up my chart and I'll show you a little bit. This might give you a little better indication just as soon as this one goes, because I really have to, my top priority is collecting this data. So, okay, so here's the chart that I used, and here is my target star. So this guy with the little red dot is this dude right here, right? And then right next to him is this little faint guy. And oh, there was some kind of a tracking thing there going on. Let's see what it does on the next image. Um, so here's this faint guy right here. This guy here is this guy. this bright, or this large dot here is this one over here, and then this big guy here is this guy, right? So you can sort of get an idea. And here's my field of view, right, inside of the purple box. And then these larger squares are actually 1/2 a degree on a side, right? So this from here to here is 1 degree square, right? This whole thing. So, the full moon would fit about in one of these big squares, right? And here's my field of view, right? So make sure that I've still got my guy in there. Looks like he's starting to move up a little bit. So maybe I'm going to, let me see what this dude does on the next image. If he's still moving up, then I'm gonna bop him down a little bit. Bop, just like that. So yeah, so that maybe sort of gives you an idea as to the piece of the sky that I'm working with. Now, when I told the telescope to slew, it actually slewed way over here, right? It was way over here. So I actually I had to star hop. I had to go over here, and then I had to go down, and then I found him, and then I found the target. So yeah, I had to star hop a little bit. Looks like that thing is bopping up again. Tracking isn't great on this, which is one of the reasons why I have to sit out here and babysit it. And I also can't really have too long of an exposure time either. And sometimes tracking is really, really good, and sometimes the tracking is really, really bad. So, just lost my target there, but I did move the telescope, so it should come in on the next image. So, I'm going to have a few lost images. I'm going to lose a little bit of data here, but the goal is to keep it just about like that. So you can see that I've got another bright star, brightish star coming in over here. That one is, let's see what that one is, according to the chart. This sort of makes a triangle here, right, in the full field of view. So that's probably, let's see, this guy is going like that. Got some funky tracking going on there. So that's actually, I guess, going to be one of these two stars. So there should be another bright star just off of the field here, but I don't care. I'm not gonna I'm not gonna worry about that. As long as I have my reference star, which I'm losing, it's going off the bottom of the screen now. As long as I have this reference star, which is gonna go off the screen here for one image, so I'm gonna lose that frame as well. Bummer. Should come back in on this next one. If it doesn't, I'll give it another. I'll give it a little shot. There he is. Okay, cool. So yeah, this is how it goes. Let's see. The chart that I'm showing, and that thing's moving down again, shows stars down to 15th magnitude. All right, so we can sort of estimate like what the brightness of that really faint dude is there. He's not the smallest one, so he's probably maybe about 13th or so. So this guy right here is about 13th magnitude. Oh, and I lost my bright guy again, but there he is. Okay. It's yeah, with a I'm not sure what an auto guider would um, do with this. If it could um, keep up with this relatively poor tracking or not. Um, but I don't care. I'm doing it manually. It adds a personal touch, and I am assured that I'm getting the data that I want and need. So yeah, very cool. Yeah, it's a pretty nice night out. Um, Nice and dark, except for the moon. The moon is definitely brightening it up quite a bit. Let's switch that over for you. You can see the full thing, mostly full. Hey, since I've got a couple of computer nerds here, I have a question for you that I don't know if I want to change it back or not. But you may notice that I've got my thing here, right, with the start and all that along this side. Now, I did not do that intentionally. I it was probably a cat um, pushed something on the keyboard to make it go into that mode. And I'm wondering if any of you um, computer nerds out there know what the command is to put the thing back on the bottom instead. Does anybody know what that command is? Because I have absolutely no idea, and I don't even know uh, what to search for in terms of like Googling it. Don't have a clue. So if any of you know how to fix that, um, or um, just to toggle, between those two, I would greatly appreciate uh, that advice. Right click on the taskbar, make sure it's unlocked, then click and drag. Oh, okay. All right. Well, I'll try to remember that. Or Uncle Bill, thanks. Um, okay, so I just have to click on it and drag it back. Do I dare try um, doing that now? Ooh, I don't know. Oh, just lost my target off the top there a little bit. It should come back in. There he is. Ooh, getting a little gust of wind right now. A little gust of wind. So, okay, well, I should just be able to grab it and drag it down, huh? Okay. Well, I'm going I'm going to try that, but I'm not going to try it now because I don't want anything to mess this up whatsoever. I'm just too paranoid. Yeah, getting a little bit of wind, just some gusts. We can check the temperature here. Temperature and humidity check. Oh, 30.4 degrees Fahrenheit, 43% humidity. Well, I lost my little dude again. I'm gonna have to. Oh, came back in. You see what the wind is doing? It's sort of whipping the image around a little bit. It'll even the slightest little wind will jostle the telescope around. Okay, that is definitely going up. So let me give him a little push. Yes, yes. Do it when the night is done, for sure. So this is kind of sort of the first eclipsing variable star that I've um, collected sort of, I guess, real reliable data on. What was it, a couple weeks ago or so? I was trying to collect data on um, on some other one, and noticed, the star streaks. Um, um, so yeah, see now it's moving off to the bottom. It's just going all over the place. Let's see what this next one does. It's probably gonna fly down. Oh wow, look at and the wind is blowing. I mean, it's not blowing hard, right? It's just slight little gusts, but it's enough to completely completely mess up. Okay, now that thing's totally going south. Yeah, you people in your 27-inch screens. I don't know. Probably gonna have to move him up one more. So I'm losing a little bit of this data, but that's okay. I I can lose a couple of images. That's no big deal. No big deal. All right, I definitely have to move him up though. Let's see what that does. So yeah, I'm going to call this the first official data collection of a variable star that I've ever done. Come on, we gotta move you up a little bit, Bubba. There we go. Still getting a little bit of gusts here. I mean, just really slight, but it's enough to really mess with the telescope. So oh, hopefully, I'm actually kind of glad that it's doing it while I'm having a little bit of trouble keeping my reference star in the field of view. If it's going to do it, now's a good time to do it when the wind is blowing a little bit. But oh, it makes it colder. It makes it feel so much colder. But I don't mind much. Not much, at least. All right, well, cool. Let's see. So yeah, they're not quite sure exactly what this system is doing. It's a pretty short period. It's something like 20 hours, right? So every 20 or so hours, this thing does its eclipse. So it's a very that's a pretty fast. I mean, if you imagine, right? These are stars. These are stars like our sun, right? Whipping around, um, whipping around each other every 20 hours. It's just incredible. Oh, that wind is cold, even though it's very slight. It's chilly, chilly. So yeah, they've tried to analyze these light curves, and they're seeing a tendency um, that is some kind of indication that there might be a third component involved. So I mean, um, uh, I don't know, Andy. Um, um, this I'm I'm gonna run it um, at least until the end of the predicted eclipse, which I think is supposed to end at 4:29 UTC. So that's another um, that's another 2 hours or so, and I get about 100 images in a half an hour. So I'm going to end up with um, let's see, if it's what what did I say, 2.5 more hours, then that's another 500. So probably about 600 images or so on this. So the thing with variable stars is that these are what are called time domain events, right? So um, things are happening through time. Things change. The brightness of this thing changes over time. So the uh, having good or decent time resolution is sort of the key here. So uh, I'm taking a sample, right, about every 15 or so seconds um, for 3 hours. So that's how it's going to go. And I'm on image number 97 right now. I know it says 95. Um, this thing, it starts from zero, right? So image number 96, as it's counted up here, is actually the 97th image. So now I'm downloading image number 98, and it looks like it's going to go out of the field. So I'm going to junk him down, and in fact I'm going to move them to the right a little bit too after this next download. Move them to the right or to the left a little bit. So we should see it come back into the field of view, but it's tracking a little bit left to right as well. So now this next image, you'll probably see it either streaking over to the left or just moved over to the left a little bit. We'll see if it is a streak or not. Oh, no, it's not. Good. So that's about the position I want it, more or less. Let's see which way it's going to go here. Looks like it's pretty stationary at the moment, which is good. Don't necessarily want to have to babysit this too much, but you do what you got to do. So yeah, so what I'll be able to do is I'll be able to use this bright star as a reference against my target. Of course, that is my target star right there. And over the course of this time, am I going to notice it dimming? Probably not. It's too gradual to really be able to see. Now it's moved down. So I'm going to move it up a little bit. So yeah, I'm not really noticing any changes. I'm hoping that there are. We'll see. Ugh, it's cold. Got a little bit of a breeze still too, which is kind of annoying and chilly. Oh, yeah, it's nasty cold. Just cold enough. I'm whining a little bit though, you know. This is the Arizona cold, which technically isn't very cold, but we'll do a temperature check here and see what it is right now. So this next image should have that moved up a little bit. There they are. Okay, let's do a temperature check. Not that I want to know how cold it is. Oh, actually, it's warmed up a little bit. 32.7. Yeah, Atta, you're exactly right. This is what actually occurs, and uh, it's for the viewer, it's very uneventful, extremely uneventful. Yeah, not much going on at all. Just sitting here counting photons, right? That's all I'm doing. I've got a CCD camera that's sensitive to light. Light comes in and gets counted, and that's it. And this image display is is sort of automatically stretching the image, so that's why these look like, you know, these big white blobs, because uh, it's just because of the stretching of this. We're looking at the muck way down at the bottom, um, but rest assured that these images actually don't look too bad. Not too bad. Um, I'll evaluate them a little bit um, and see if any improvements can be made to the mount, or to how the camera is mounted. But it actually looks pretty good. Not too bad. Not too bad. So yeah, I'll use this guy as a reference against that guy, and assuming that this one stays steady, I'll be able to measure the brightness of this guy relative to that guy. And what I should see is that over time, this one will dim um, to a certain point, and then it'll um, um, start to brighten up again. We'll see. We'll see. We'll see how close the prediction is. Every single one of these images are time stamped as well, right? So in the actual metadata, which is part of the FITS image, um, is a timestamp, and that timestamp is um, just the local time, but it's down to the second, so that's good enough. And so what I'll do, right, is I will plot the difference in brightness between this one and this one versus time. And what I should see is if the relative brightness is changing, then I should see that. We'll see. Looks like this thing is going up out of frame again. Okay, let me scooch him down. Just like that. All right, well, that's what it's all about. Just collecting photons. We're now definitely into the actual dark dark sky here. I'm looking up over my right shoulder at the constellation Orion, which is way up way up in the sky, about as high as it's going to get, passing what's called the meridian, which is a line. It's sort of the north-south line, right? If you take the North Pole, right, or the South Pole, right, um, depending on where you are on this sphere. If you take the pole and you draw a line between the pole and your zenith, and your zenith is that point right straight above you. Um, um, that line that goes between the pole and the zenith is called a meridian, your local meridian. You know, Andy, I could make it red, but I'm not doing any kind of visual observing at all. This is a camera thing, and the camera is connected to the telescope, and the telescope doesn't really care all that much. Ooh, I've got a kitty fight out here. Great. Um, so yeah, this doesn't affect my eyes at all because I'm not actually looking through the telescope or anything. I'm just having the camera do that instead. So I'm not uh, as concerned or worried about red red light. I could definitely do it, and it probably wouldn't hurt to do so. Um, but it's not going to matter. Doesn't matter one bit. Now, I mean, if I had a searchlight, right, or a spotlight here, yeah, I probably wouldn't like that. But I've got a faint little screen. It's not shooting any photons into the telescope itself, so I'm just not concerned. Not concerned at all. Let's see if this. Okay, it went down a little bit. Let me poke him up. Poke him up one. And see if it comes back in on the next image. It should. We're up to image number 139. Yay. I don't know, Andy. I think those kinds of things happen from time to time. I don't know enough about any of that to be sure about those kinds of things, but that happens, from time to time. Not too often, but I think a magnetic pole flip. I think that's a thing that happens, and I don't know if we really understand what what the consequences of that is. So yeah, I think we're I mean, it's gonna happen whether we want it to or not, I think. So we're just gonna have to sort of deal with the consequences of that. If there are negative ones or positive ones, I don't know. I don't know enough about any of that stuff. I'm gonna lose that bright star down there again. Arr, arr. Okay. Bop him up a little bit. Boop. So this next image, you'll see that this little guy is going to fly off the end. But then in the next image, he'll come back. just barely on the edge there. But now I've moved the telescope a little bit, so it should shoot back up. Boink. Maybe a little bit too much, but that's okay. As long as I've got these two guys in the same field of view, I am good. So don't really care where they are because I've got software that can deal with all of that. I've written my own software to deal with all these things. So no problem. No problem at all. I think you can probably buy software to do this too, but you know, I yeah, that's it's a lot easier for me just to write a new piece of code, to deal with things than it is to try, to find, to buy stuff. Now, I mean, most people don't have, the ability to write their own code, so I understand. But I do, and so I take full advantage of it. Totally. What was that last comment? Andy, I hope it doesn't happen anytime soon. Yeah, yeah. Well, I mean, Atta, maybe it's gonna be a positive thing. No, I don't know. I don't know enough about any of that stuff. The sun does a pole flip. Um, wow, that happens. What, once every 22 years or once every like 11 years? It does a pole flip. Is that right? So you know, I don't know. I don't know. Anyway, well, wow, we're almost up to the hour. Amazing. Um, yeah, yeah. I think the poles flip around all the time. So I don't think it's I don't I don't think it's that huge of a deal. I don't know. I don't know enough about any of that stuff. Dun, 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 dun. Okay, he's moved out of the thing. Oh, you know what? I wanted to give a little bit of update on my um, lunar telescope project. I actually emailed John McGraw, who was the lead um, scientist with the LUTE project, LUTE, which was a project to put a 1 meter telescope on the moon back in the early 90s. And I got a hold of him, and he was very, very encouraging. Um, he actually said that about a month ago he was contacted by somebody at NASA saying that, hey, maybe they want, to do this again, try this again. Now, I don't really have any interest in having NASA do this. I think that would be almost a disaster. Um, I want this to be a privately funded um, commercial operation. I, really, um, I want NASA, to sort of say, you go for launch, and that's about it. I don't really want NASA involved. um, but no, he was extremely encouraging and said, I mean, he basically made himself, totally available. If I have any kinds of questions or anything, so yeah, I'm pretty encouraged by that. Of course, I will keep everybody um, updated on that. I think it's a really, really interesting project. One thing that he did mention, which I think is extremely relevant, is that you really got to find a good reason, right? You got to find a really, really good reason to plant a telescope on the moon. And if it's just to, you know, get out of the atmosphere of the Earth, that's not a good enough reason, right? You can put a satellite up and, you know, that'll be fine. Um, if you want to look at the sky in different wavelengths, like the ultraviolet or the X-ray or anything else, you also, it's all that you have to do is get out of the atmosphere, right? You don't have to have anything on the moon. So why put a telescope on the moon then, right? Well, I think there's at least one good reason, and that is that when you have a telescope on the moon, you can observe your targets for very long periods of time, right? When you're in orbit, going around the Earth, your maximum amount of continuous time that you have on a target is is maximum 45 minutes maximum, right? It's more like 30, right? But if you're sitting on the moon, you can actually sit on the same target for almost 2 weeks straight, right? So imagine doing this, what I'm doing now, for 2 weeks, right? Every, one image every 16 seconds for 2 weeks, right? That's pretty amazing. You can't do that from orbit at all, right? But you can if you're sitting on the moon. So that is one advantage, right? Um, and there may be others. So anyway, um, that's just an update with that. I think I'm gonna let you folks go. I'm gonna be sitting here collecting photons for the next couple hours. Um, yeah, I think I'm probably gonna go until about 5 hours UTC or so. Um, so I've got a couple more hours at least, 2 or 3 more hours at least. So yeah, I'm just going to sit here and collect photons, and that's that's what's done. Yeah, if you're collecting your own data, um, this this is how it's done. We're slowly moving into an era where we're not going to have to collect this kind of data all that much anymore, right? Because we're going to have it, just available. Um, but for now, I think um, that. But yeah, Uncle Bill, I totally agree. I mean, I mean, imagine a 2 week long exposure with you know, I mean, I'm proposing a relatively small scope, something around 8 inches, maybe 16 inches, maybe 20 inches max, um, maybe something more, but you know, I'm trying to be conservative, I guess. Um, but even with an 8-inch scope, if you have a 2 week long exposure time, ah, wow, yeah, that would be really really amazing, really amazing. All right, well, cool. I'm gonna go. I'm gonna scooch these guys down a little bit, and I think I am definitely going to let you all go. So I'm so glad that you all came in here to this OBS session. Um, it's possible that I'm going to be clear tomorrow night again. Haven't decided um, what I'm going to do about that. Um, you know, I've uh, I've got a number of different possible projects, And so I want to be able to collect some data on all of them, just to sort of see what can be done. Um, so it's possible that I will be out here again tomorrow on a different target. Don't know what it's going to be. Don't even know if I'm going to, right? But I will definitely keep you all as informed as I possibly can. So for now, I think I'm going to get out of here. I'm going to show off show off the head shot one more time, and bid you all a great evening, a great day, and you know keep your hats on. We are spinning really, really fast, but it's a really, really smooth ride. And yeah, I'm just going to be out here watching this star fade a little while longer, and then hopefully be brightening